In this class, let us study about trigonometry. You must be aware of some other branches of maths like geometry, which deals with the shapes and figures and their properties, arithmetic, which is the study of numbers and their properties. Similarly, the word trigonometry literally means the study of triangles, but that is not what it is. It is actually the study of the relation between the angles and the sides of a triangle, in particular a right angle triangle. So here I have a triangle. It is right angled at A. Now from any of the other two angles, randomly choose one. I have taken this and I have named it theta. Theta is just a Greek alphabet, just like you have alphabets in English. In Greek you have alpha, beta, gamma, delta. Theta is just one of them. I have named it theta. Now all our measurements from here onwards will be with reference to this particular angle. Now, with reference to this particular angle, tell me what will be the opposite side. The opposite side will be the one which does not touch this B. So, what is that? This will be your opposite side. What will be the adjacent side or the nearby side? Any side which touches this B will be an adjacent side. So this will be your adjacent side. Now technically this is also an adjacent side, but a more precise term for it will be what? It will be the hypotenuse. And you know, what do you know about the hypotenuse? It is the largest side, and all the three of them are related by the Pythagoras theorem. So here you have three measurements, right? From this, take two at a time and form a ratio, as in form a fraction with a numerator and a denominator. Now with these three you have to consider all the possible combinations. Think of all the permutations and combinations with these three sides. Then how many ratios will you get? 2, 4, 9, 100, how many? This many is what you get. You get 6 combinations. When you take 2 of each and make a ratio, you will get 6 such combinations. Now we cannot keep on saying opposite side by adjacent side, opposite side by hypotenuse. We can't keep on saying that, right? So let us name them. We don't have to name them. The mathematicians before us have already done that. We just have to write down the names. Now I have written down names for these 6 ratios: sine theta, cosine theta, tangent theta, cosecant theta, secant theta and cotangent theta. And I have written the abbreviations with the sine theta, cos theta, tan theta, cosecant theta, sec theta and cot theta. We just give the abbreviations like this. Write it in short form. Now comes the important question. When I said name them, I did not just write sine, right? With each one of that I have written a theta. Why? Why have I connected a theta to all of that? This brings us to the first property of trigonometric functions. What is the first property? The first property is that each one of them is a function of theta. What do you mean by function? Where have you heard the word function before? You have heard of polynomials, right? When you are studying algebra, you would have heard of polynomials. For example, here you have p of x. Suppose p of x is equal to x plus 100. Now, what do we mean by a function? It is a relationship between two quantities where one is independent and the other is dependent. What do we mean by that? The x here is independent. It can take whatever values it wants. It can be 0, it can be 100, it can be 2, it can take whatever values it wants. But then your p depends on it. Once you have fixed your x, your p of x, for example, p of 0 has to be 100. Your value of p is dependent on this x. X is independent, p is dependent. Similarly, p of 100 has to be 200. So why is that? Because this is a function of x. So just like your polynomials was an algebraic function, your sine, your cosine, your tangent, they are all trigonometric functions. Functions of what? functions of this angle. You remember what I told you? Trigonometry, we call it the study of triangles, but it is actually the study of the variations of the angle. So each of this, sine, cosine, tangent, all of them are what? These are all functions of angles, which means your angle is independent. It can take whatever value it wants. It can take 30 or 60 degrees or 40 degrees or whatever. Your sine value will keep on changing according to it. Now that was the first property. Sine, cosine, tangent, all of them are what? They are all trigonometric functions of the angle, not of the side, but trigonometric functions of angles. So when I write cos theta, I do not mean cos into theta. It is not a product. It is how we usually express functions. We write functions like this and we read it as function of x. Now this is the same concept. We just don't write the brackets. We just don't say the word of, but it means the same. The concept is same. All of these are functions of your angles. Now the second thing that we learned today is two different units for measuring your angles. Now you are familiar with one of them. You have been using degrees to measure angles all your life, right? Today you are going to learn one more unit. Now tell me, how many degrees do I need to complete a revolution? This will be half a revolution. It will take me 180 degrees. This will be a complete revolution and this will give me 360 degrees. Now the same thing in radian. Half a revolution will be pi radian. A complete revolution will be what? It will be 2 pi radian. Now we will use this information and find out a formula to convert a degree and radian into each other. Now this is the information that we have. 360 degrees is equal to 2 pi radian. Now just take this equation, divide throughout by 360 degrees, then what will you get? 1 degree will be equal to pi by 180 radian. Now let us find it the other way round. How will you get 1 radian? Here you have the value for 2 pi radian. How will you get it for 1 radian? Divide throughout by 2 pi. You have for 2 pi, divide throughout by 2 pi, then you will get the value for 1 radian. 1 radian is 180 by pi degrees. Now we are usually dealing with degrees, right? So here I have written down some of the values in degrees. Tell me how much is it in radians. Here it is 180. From 360, how will I get 180? Just divide throughout by 2. Then here I will get 180 and here I will get what? Pi radian. Now how am I going to get 90 degrees from 180 degrees? Again divide by 2 throughout. So this will be 90 degrees and this will be what? Pi by 2 radian. How will I get 45? Again divide by 2. That will be what? Pi by 4 radian. Now what about 30? I will go back to 90 and divide it by 3. Then I will get 30 degrees here and here I will get pi by 6 radian. Then how will I get 15? Again divide by 2. You will get pi by 12 radian. And what about 60? How will I get 60? I already have 30, right? Let me multiply it by 2. Then I will get pi by 3 radian. Now some of these values you are going to see again and again. So please try to remember. There is a very interesting way to remember this. 60 degree is pi by 3 radian. But 30 degrees is pi by 6 radian. Just notice the patterns. Throughout trigonometry, you will see the patterns. If you see the patterns, it is very easy to remember. 6 and 3, 3 and 6. Now, before I go to the third property, let me just tell you something. From this equation, how do you get this equation? We said all you need to do is divide by 3, right? When you are dealing with whole numbers, divided by 3 will be very easy to do. But a shortcut when it comes to fractions, a shortcut is multiply by 1 by 3. Now this has got nothing to do with trigonometry. This is basic maths, basic multiplication. Whenever you divide by a number or you multiply with its reciprocal, your answer will be one and the same. You can try that out yourself. 100 divided by 2 will be the same as 100 into 1 by 2. Your answer will be same, but then I have just written it in two different ways because when you deal with fractions, this will be more easier to do. Now consider for 15. For 15 degrees, what will you do? You just have to divide this by 6 or multiply this by 1 by 6. Now try doing that. You will get this answer very quick. That's just a shortcut. Now we will go on to the third property. Now we move on to our third property. All of your trig functions, sine, cosine, tangent, all of them are unitless. What do we mean by them? Their answer will be a plain number. You will not see any kilometer, meter or degrees or radians. You will not see anything next to it. Your angle is measured in degree or radian. Your sides are measured in meter, kilometer, whatever. But your final answer will have no unit. Now we are going to study about two special types of triangles. If you notice, I have written down only their angles. We have no information about their sides. That is a problem. Why? All our trig functions, all our trigonometric functions are functions of angles, but then they are represented as what? Ratio of sides. Now, what is special about this set of angles? Even if you have no information about the sides can be anything. Even if you have no information on the sides, you will still get the ratio of the sides. Shall we see how that works out? So there we have our triangle. What do you see here? Two angles are equal. That means the sides opposite to equal angles are equal. That means if this is A units, this is also A units. Now what sort of a triangle is it? It is an isosceles right triangle, and the missing side is the hypotenuse, which is the largest side. That is what is missing. And how will you find it? Using the Pythagoras theorem. How will you find that? Take the two short sides, square them, find their sum, and then the square root. There. This is your hypotenuse. So when you find sine 45, always remember sine goes to the opposite side. It is opposite side by the hypotenuse. So you will get what? You will get 1 by root 2. Why is this a good news? You do not see the A there. You do not see the variable. You see a neat numerical ratio. Cos 45 is also 1 by root 2. Your tan will be this numerator by this numerator, which is what? 1. So isn't that good news? We started with just the angles, but we have got a side ratio. Now we will go to the second triangle. So here we have a problem. What sort of a triangle is it? It is a scalene triangle. The ratio of the sides can be anything. The sides can be anything. There is no relation which binds them. Then what is the third triangle left? Based on the measurement of the sides, we classify the triangle into three types, right? An isosceles triangle, a scalene triangle, and what is the third one? An equilateral triangle. That is all we are left with. So though that is what we want, we will start from here. We will start from an equilateral triangle. All angles are 60. All angles are equal, which means what? All sides are equal. Now I have taken 2a. You can take a as well. In the next step, we are going to find half of 2a. So it will be easier to deal with a. If you start with a, Then the next step, if you take half, you will have to deal with a by 2, which will be a fraction. It is better to deal with whole numbers. That is why I have taken 2a. So I have taken such an equilateral triangle. Now I will draw a perpendicular bisector. What is a perpendicular bisector? It is a line which you draw from one vertex to the opposite side, which meets it at a right angle and bisects it. What do you mean by bisect? Cut into two equal parts. There. Now, we don't need this. We are done with this side. Now just look at this triangle. A 90 degrees, a 60 degrees. So what will be the third one? A 30 degrees. Have we got the same one? We have got the same triangle, and we also have two sides. What is the third side? What is the missing side? It is one of the shorter sides. So square both the hypotenuse and the other shorter side. Find its difference, because it is the shorter side which is missing. So the longer side minus the other shorter side. So this will be your answer there. Using this, we can find the other trig functions. So now let us find sine 30. Sine always deals with the opposite side. Remember that? So sine 30 is what? A by 2a. Your a gets cancelled, and what do you see here? You have a ratio of sides which does not depend on any variable. It just deals with what? With numbers. You have a numerical ratio. That is a good news, right? Similarly, cos 30 is what? It will be root 3 by 2. Now we come to 60. What do you see here? The one which is the opposite side of 30 is the adjacent side for 60. That means the value which is the sine value for 30 will be the cos value for 60. And what is the cos value for 30 will be the sine value for 60. So this is how you find the sine and the cos functions for 30 and 60 degrees. What is the sine function of one will be the cos function of the another one. Why is that? Because what is the adjacent side for one will be the opposite side for the other one. Now first we start with the table method to memorize the trig function values from 0 to 90 degrees. What have we done here? We have arranged all the angles in the increasing order. Now to find the sine values, all you have to do is write from 0 to 4 again in increasing order. That is all. These are your sine function values. Now, what do you notice here? These are not in their lowest form, right? So I will reduce it in the lowest form and you see how it looks like. Now, when I reduce it in its lowest form, this is how it looks like. The values start from 0 and increase and reach 1. Now we move on to our cos functions or our cosine functions. They have the same set of values but in the opposite side. They start from 1 and slowly decrease towards 0. What always comes next to 1? Next to 1, root 3 by 2 comes. Why is that? This is 2 by 2, root 3 is 1.7 and 1.7 by 2. Then after that what comes? Root 2 by 2 comes. Why? This is 1.4 by 2. So you see the values are slowly decreasing. Your denominator remains the same, but what is happening with your numerator? Your numerator is slowly keeping on decreasing. So these are your cosine values. One increasing, the other one decreasing. Now we will use this table and find the rest of the values. How will we find the rest of the values? A very easy way to remember what is the reciprocal of sine and cos is just remember C and S. So when this is sine, its reciprocal will be cosec theta. If this is cos, its reciprocal will be sec theta. Remember S and C in each one of the combination. And the last one will be tan and cot. These are related to one another. These are the reciprocals of one another. These both have a t in them. That is a very easy way to remember. Each of these combinations will be the reciprocals. Each one starting with a c and a s. Please remember that. Using this, we will complete the table. I have written down the whole table here. So this is the first thing you should notice. When your theta, when your angle makes a journey from 0 to 90, your sine also keeps on increasing from 0 to 1, but your cos values decreases from 0 to 1. That is the first thing you will notice here. Now you saw trig function values for angles from just up to 0 to 90 degrees. Now what you will study is some general properties. Properties where your theta can be anything, not just 0 to 90 degrees. That's what we saw just now. But for any angle in the world, any angle that you can think of, 200 degrees, 500 degrees, this should be same. These values hold for any theta. The first one is what all values can your sine theta take? Can your sine theta be 2? That is the question. The answer is no. Your sine theta and your cos theta have to lie between -1 and 1. Have to lie in this interval. Why is that? Why can it not be less than -1 or more than 1? Why? Let us find that out. What is your sine theta? Your sine theta is opposite side by hypotenuse. Suppose what I have written down is wrong. Suppose it can be more than 1. There. It is more than 1. That means what? By cross multiplication, your opposite side will be greater than your hypotenuse. Now that is a problem, right? Your hypotenuse has to be the always it has to be the greatest side. Similarly, if you take cos theta, that if you take is greater than 1, you will have the adjacent side is greater than the hypotenuse. That can never happen. So both of these, sine theta and cos theta, have to lie in this small interval. It cannot go below -1 or it cannot go above 1. Now we come to the cosec theta and the sec theta. What about them? They will just not take this value. They will take all the other value. You see what is happening here? It will always be less than -1 or greater than 1. Why is that? The same logic that we have used here. Suppose your secant theta can be less than 1. It can fall in this place. Suppose. Then what will you get? Then you will get your hypotenuse by your adjacent is less than 1. That means what? By cross multiplication you will again get your hypotenuse is less than adjacent side. That cannot happen. Opposite side and adjacent sides will always be lesser than the hypotenuse. So what I am saying is, if you take the entire number line, you remember your sine and your cos and all your trig functions, they are all unitless. They are just numbers. So I will take the number line. If I take the number line, all your sine and your cos functions have to lie in this small place. But then your sec and your cosec will not lie here. This is just for sine and cos. They will not go outside this. But your sec and cosec will not come inside this. They will be all over the other place. And the good news is your tan and your cot have no such limitations. They can go wherever they want. The whole of the number line, your tan and your cot you can find anywhere in the place. Now we come to the last set of properties. Your sec theta and your tan theta is not defined when your cos theta is 0. Why is that? In a fraction, Having 0 in the numerator is fine, the whole fraction will become 0. But then having a 0 in the denominator is not good, it is bad news, because the whole thing will tend to infinity. So what do you have here? If your cos theta is 0, your sec theta and your tan theta will not exist. Similarly, if sin theta is 0, your cosec theta and your cot theta will not exist. Why? Because both of them have sin theta as their denominator. That is why. Now I have just written down two examples. If theta is 0, cosec 0 and cot 0 will not exist. Now 0 is just one of the examples. Remember, your sin theta and your cos theta are periodic functions. What do we mean by periodic functions? Which means after a certain period, after a certain interval, the values keep repeating themselves. For example, your sin pi, here I am taking it in radians, okay? Sin pi, after every 2 pi you will get the same value. Whatever is the value for sin pi, just keep on adding 2 pi. This will be the same value, this will be the same value. The values just keep on repeating. So if sin 0 is 0, not just sin 0, add 360. For every 360 you will get the same value. Sin 360 is also 0. Sin 720 is also 0. Keep on adding 360, all of their sin values will be 0. Similarly, if you take the cos values, it is the same. They are also periodic. So it is not just 0. For 360 degrees also the story is same. The 720 degrees also the story is same. Your cosec theta and your cot theta will not exist for all of these values. Now you saw the table, right? The same thing you can find out using your hands also. This is only for your sin values. What you do is write down the number of fingers below. After this below, do you have any fingers? No. So this is 0, 1 finger down. So 1, here 2, here 3 and here 4. Just count the number of fingers below. So just using your hand also you can find the sin values. So once you find the sin values, the remaining is easy, right? The same way we did with the table, using your hand also you can find all of these values. Now that's all for today. What did we learn? We learned about 6 trigonometric functions and 5 special angles. But that is not enough, right? We use trigonometry in astronomy, in aviation, in building bridges and all of that. So just this set of angles is not enough. We need to know about bigger angles, smaller angles. So how are we going to do that? We will do that using the unit circle. What is the unit circle? It is a circle which is constructed in the XY axis with the origin as the center and unit radius. Unit just means 1. Its radius is 1. We will construct this circle, and using this diagram we will know the trig functions of all of these angles. Now don't be afraid, don't think you are going to get a new value or you are going to study completely new numbers. No, it is exactly the same numbers. 1 by root 2, root 3 by 2, and all of it is going to be same, but just depending on which quadrant they fall on, your angle falls on, you will see different signs. Some positive, some for which sign is positive, some for which sign is negative. You will see different combinations, and all you have to do is know the pattern, know what pattern it follows. But then that is for another day. Till then, Assalamu alaikum.